Alright, so today is day 76. I solved one more little problem, the tries, the word search 2. So we finished already with tries. This problem is quite hard. I didn't submit it. Thing here, alright. But yeah, I'm not gonna redo it because it's very long. But I can give the intuition if I watch the video again, so I have it. So first, the outline of a problem. We're given a board of characters, and we're given also a list of words, and we want to know which words appear on the board. The first and most important constraint is if a word has repeated characters, it doesn't take into account the same character, like the previous character, to form the word again. Right? So for example, I have the word, I don't know, S with double A. SAA is just one way of doing it. Like you cannot do SAA and use only this node. This is very important because otherwise the problem is like infinite, or I don't know, like much more complicated. Alright, so the first observation here, I mean, my first main solution was, for first you take like every cell and you're gonna perform DFS looking for each word. So you search for bad. I mean, here doesn't start with B, so you skip. Now you search, it starts with B, so you search for bad. You can go either up, down, left, or right. So you do DFS on the neighbors, which you know it's only 4, and you do this for every word, and then you realize that this is very complex. Like it's very inefficient because doing DFS over the whole word for each word, like it's too much. So one thing that you can do is take into account that the objective, what you want to do, it's actually search some words. So when you search for bad, you know that you are searching, there will be another word that starts with the same prefix. So you can use this as your advantage and directly make a try and use the try as a map to search within the matrix, within the board. So that's essentially the main intuition of it. But the implementation is quite messy. So first one, this is a normal implementation of a try. Right? The main difference with the previous implementation is this one. Now instead of saving like the end word to be true or false, a boolean value, now it's the actual final word because we're appending it into the result. And yeah, for the solution, first we check the edge case, that if it's empty. If we don't have any rows or columns, or we're not given a word, the solution is empty. We instantiate the try, right? So we add all the words. So we have like a graph that we're gonna use, right, as a map. And then we, for each cell in the board, we're gonna perform DFS only once, right? We do here like a micro optimization, because we are saying that if the try doesn't have a children, so if there is not the word that begins with the character that we're searching for in the board, we're not gonna perform DFS, right? I mean, this is taken into account inside the DFS, because once you do DFS, you check if the node is none, and the node is gonna be none if, when you try to get the children, the character of the children of the board, the corresponding board, is none. But I mean, this is like a previous optimization, or whatever. So you perform DFS over each cell, then the DFS is, if the node is known, you return empty. You also check if you are like at the end of the node, because if you are at the end of the word, so know that the word is gonna be not known. So it means that you found a word that it's in the try, right? So you're just gonna append this into the result and mark again the attribute as none, because it means that you don't want to find duplicate words, because in the board you can find many words that have the same, I mean, you just can find in different positions the same word, but you're not interested, right? You just want to output the first time you see the word. So that's it. So you're essentially modifying the try, so it says you're not taking this into account anymore. But here is not the pruning yet. You actually do the pruning at the end. And the pruning is something very smart, because you have like the tree, and once you used a word, you prune all the nodes until you find, it's like pruning all the branch until you found, while the node doesn't have other children. So you're saying like you are removing from the try all possible nodes that will not make you find another word, because the last attribute is going to be none, the last attribute of not word. So you check either of those conditions, so you directly delete it from the try. So as more as you search, the more efficient it gets, because try is smaller, and at every instance this is going to be faster. Alright, so you search, you do DFS, you pass two attributes, which is the rows and columns, and you check if you can actually move. Normally you have four neighbors, up, down, left, and right, but if you are like here, you cannot move neither up nor left, so you just safeguard like those cases, right? So if you are in this area, so it means that the rows is greater than 0, and the character that you're gonna move into is not a hashtag, because you make it a hashtag if you already use it, because you don't want to reuse the same character for the same word, and perform DFS over that character that you're moving into. When all of this it's done, you're gonna clear again that cell in the board, so when you search for another word, you can use it in the board, right? And this was the pruning, and in the end you return result, and that's it. But it's quite complicated. This problem, I think probably I need to do it like three more times or four more times to truly get it. But the main intuition, I really understand it, so that's fine. So that was it for today.
I don't